Hello everyone, welcome to the video on basics of mathematics. So in this video we will cover remainder theorem, some important identities in mathematics, laws of indices, ratio and proportion, and we will talk a little bit about number systems. So let us start with remainder theorem. So in remainder theorem, suppose px be a given polynomial and it is divided by x minus a, and assume that the quotient on dividing is qx and the remainder on doing all the calculations here is finally r. And obviously degree of px is greater than equal to 1. Degree of px is greater than equal to 1. And an important point to note here is that the degree of remainder is always less than that of x minus a. This you must have studied in your high school. Now if I put all these together in one particular formulation, then I can get the formula as px is equal to x minus a into qx plus remainder. This is normal division, as everybody must be knowing. For example, if I divide 5 by 2, so the quotient is 2 and the remainder is 1. So I can write it as phi is equal to 2 into 2 plus 1. Now let this equation be equation number 1. Now putting x is equal to a in equation 1, we get PA is equal to a minus a into qa plus r. Now as you can see, a minus a is 0, so this whole term becomes 0. So PA is equal to r. This is nothing but remainder theorem. It states that if any polynomial of degree greater than equal to 1 is divided by x minus a, then to find the remainder you just need to put the value a in place of x in px. So I will just write it down, the theorem for you. So the theorem is as follows. Let px be any polynomial of degree greater than 1 greater than equal to 1, and a be any real number if px is divided by x minus a, then the remainder is pa. So this was about remainder theorem. Let us see an example on remainder theorem. So given px is equal to 2x square minus 5x minus 1. And this polynomial is divided by, this polynomial is to be divided by x minus 3, then find the remainder. So simply a remainder will be equal to P3 by using the remainder theorem. So remainder will be P3, so putting 3 in place of x in Px, 2 into 3 square minus 5 into 3 minus 1, that is 2. Now we can also verify this by doing the actual division by using the process of division. So it is as follows: 2x square minus 5x minus 1 divided by x minus 3. Just consider this section. Okay. So x minus 3, first of all we have to see two terms. So x minus 3, for dividing it we need 2x. So we will get 2x square minus 6x. This will get cancelled out. Sign change, this will be x minus 1. Now for dividing x minus 1 we need plus 1. So we'll get x minus 3. This will get cancelled out. Sign change, 2. 2 is the remainder by actual division, and through by remainder theorem also 2 is the remainder. So therefore this we have just shown a verification of remainder theorem. Now we move on to some important identities in mathematics which are frequently used. They are always useful to just look up at. So first identity is a cube plus b cube is a plus b whole cube minus 3ab into a plus b. And another form of the same identity is a plus b into a square minus ab plus b square. You can check this out by taking common a plus b from the previous result. So on taking a plus b common, you will get a plus b whole square minus 3ab, and a plus b whole square, as we all know, is a square plus 2ab plus b square. So minus 3ab. So 2ab minus 3ab will be minus ab. So a square minus ab plus b square. And similarly, a cube minus b cube is a minus b whole cube plus 3ab into a minus b. And that can be simplified too, or this is just the another form of this identity. So depending on the type of question, you can use either this or this: a minus b into a square plus ab plus b square. Now third identity is a plus b plus c whole square is equal to a square plus b square plus c square plus 2 into AB plus BC plus CA.